Okay, now we're going to be working with explicit and recursive formulas to dealing with arithmetic sequences. All right, so this first one is the explicit formula, and it just tells us that if we know the number of terms, so if we want to find, say, the 100th term of a sequence, we would say a sub 100. N is the number of terms in a sequence. So n equals the number of terms. A sub 1 is the first term, and D represents what we spoke about in the last video, the common difference. So let's go ahead and do an example of what we're talking about so it makes it easier to see. So here we have this sequence, 2, 6, 10, 14, 18. And some of you right away said, well, I know what the difference is. It's 4, because 6 subtract 2 is 4, 10 subtract 6 is 4, 14 subtract 10, 18 subtract 14. They all share a common difference. Well, the first term in that sequence is 2. And then if you count 1, 2, 3, 4, 5, the number of terms is 5. Well, if you know these three things, if all of this information is explicit, it's visible, you can see it, you can then plug that in to this formula right here. So n is 5, a sub 1 is 2. Well, n subtract 1, 5 subtract 1, and the common difference is 4. So let's see what that would be. So it would be 2 plus, well, 5 subtract 1 is 4. 4 times 4 is 16. And 2 plus 16 is 18. So this says that the fifth term in this sequence is 18. 1, 2, 3, 4, 5. The fifth term in that sequence is indeed 18. And I think that that's all I did down here. Now if we want to find the 12th term, so let's say I told you this keeps going, I'm not showing you what the other terms are, and I'm not counting by 4, this explicit formula makes it really easy. So we're going to find the 12th term. So we know that we know that n is equal to 12. Well, the common difference is still 4, and a to the first term is still 2. We could plug all that in. The first term is 2. We're talking about the 12th terms. So 12 subtract 1, which is 11, and the common difference is 4. Well, 11 times 4 is 44. 2 plus 44, so the 12th term, a sub 12, is 46. Well, let's count by 4s to see if that's true. So 18 plus 4 is 22, then 26, 30, 34, 38, 42, 46. Well, here we have 46. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12th term is 46. Okay, now we're going to talk about the recursive formula. Recursive formula is not when you have all the information explicitly, but it's based on the previous term. So you can find a term, say a to the 100, if you know the 99th term plus the common difference. So the task would be find the 13th term of that previous sequence. So remember the previous sequence, the difference was 4. The first term, or a sub 1, is 2, and we found that a sub 12 was 46. Well, knowing that, we can plug it into the recursive formula. So we're going to try to find a sub 13. Well, a sub 12, which is 13 subtract 1, was 46. The common difference was 4. So a sub 13, the 13th term, should equal 50. And if we added 4 more to that, the 13th term would indeed equal 50. All right, so now a series. Remember what we spoke about originally? A series is just when you have a sequence and you add up all the values. And we're learning some new notation. This notation right here is the Greek symbol sigma. And this right here, so let me show you what all the terms, all the notation represents. This notation right there is the summation, meaning the sum of things. The capital L is the number of terms. A sub 1, again, is the first term, but A sub L would be the last term in the sequence. And S sub L is this means it's a series. A means it's a sequence. Sum of terms. So let's go ahead and see what the formula is for a series. Formula is the sum of all of the terms is equal to the number of terms divided by 2 multiplied by the quantity of the first term plus the last term. So here's an example. We have this sequence, 1, 3, 5, or counting by odd numbers. So we need to know how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of terms is 10. The first term is 1. The last term is 19. And now we can plug it into there. So the sum of, I just almost made a mistake. L itself is the number of terms. So the sum of the first 10 terms in that sequence is equal to 10 divided by 2 multiplied by the first term, which is 1, plus the last term, which is 19. So the sum of those first 10 terms, 10 divided by 2 is 5. 1 plus 19 is 20. So the sum of the first 10 terms of that sequence is 100. And here's a really quick way to check. The interesting thing about arithmetic series is the first and the last term, if you keep doing that, add up to the same thing. 1 plus 19, 20. 3 plus 17, 20. 5 plus 15, 20. 7 plus 13, 20. 9 plus 11, 20. 1, 2, 3, 4, 5. 5 times 20 is 100. Okay, so that's the summation notation and the formula for an arithmetic series. And we spoke about recursive formulas. Recursive formulas are based on, we can find a term based on a previous term, or explicit formula when we know specific or explicit information. Okay, that's it for this.